looks nice.
Does it look like it?
No, I cut my hair, but like.
Oh, no.
It looks really nice. Over COVID, I cut bangs.
Ooh.
Yeah.
That's brave.
Yeah.
All right. Well, while we wait to get started for the bell, we'll do our number talk in a second. Just to preview kind of the end of this, and for those of you that have been gone a long time, we need to get caught up because I'm going to tell you this is where the material starts to escalate a little bit. So you don't want to be doing Unit 8 stuff while we're doing Unit 9. Just really not recommended. You want to be able to focus all of your efforts on Unit 9. So I believe there's about 8 of you that still owe me the quiz on 8.1 to 8.4. I would make it your goal to do that by the end of this week, to the point where I'm going to start sassing you and your parents if that is not done by the end of this week. Because we're looking at testing kind of in the middle of next week for Unit 8. And you're going to want some feedback on those tests before you get started. And by tests, I mean all of the alternating series tests. Alternating series tests is going to be today, but all the other tests. You want some feedback on that. We'll probably do some more focused talk on feedback next time. I did grade the quizzes of those that took it last time. In general, they were good, but I did have a lot of feedback on like notation and things. So make sure when I pass those back, and I can pass those back at the end of class for those of you that did it last time today, there are some spaces where I made some notes and things. It's just all of this, it's really important how you write stuff down. So you're going to notice I'm being a lot pickier about some of that stuff today. All right, who are we missing? Just James L. Sushant. Is he sick? He's been gone. I feel like the last time I saw him, he looked really tired, and that's not like him. Okay. All right. Well, let's send good vibes to Sushant and James L. I don't know what he's doing, but. All right. So what we're going to be doing today after we do that number talk is we're going to be learning alternating series test. This test is very easy to do, and it's actually relatively easy to find out which series you need to do it to. There are a little bit of extensions towards the end of it. So we've got an alternating series error bound. So there's some extras at the end. The notes are kind of long to the point where we're not going to do a notes check today. Instead, what we're going to do is pull out our problem sets and find the couple of tests questions where we can use the alternating series test and just literally do those questions on the problem set as like our notes check. So let's go back to that number talk. That's a Google Meet. All right, how much does the pink dumbbell weigh? 2.5 is saying?
Yeah, I'm also going 2.5.
All right, hold on. Annotate. All right, who's on the 2.5 frame?
Wait, actually, it's a lot smaller.
2.5 pounds is not very heavy to be fair. Joe?
Yeah. I'm 2.5.
Okay, yeah, I'll stick with
The twins are
What?
The twins are Ashley do.
Yeah, wait, no, that thing's way small. That thing's like 0.5 pounds. It's like regular size.
All
right. Who wanted to see this? You wanted two. Who wanted two?
No, we wanted one and Ashley. You know? Yeah, might be like really big. It depends. Yeah. No.
All right.
And
Connor. I don't know. I haven't looked at them. 10 grams?
4 pounds.
4.
Oh yeah.
Saji?
Less than half of like. Is it just one dumbbell?
Lily?
And Cora is with me on 3.
3,
I have also a I said 1.5.
4.
I think you
Yeah.
right.
Jesse said 1.5.
Yeah, we're not getting stronger. We're getting stronger.
All right, I can't write today. Brandon?
1.
What is Ella?
That's 1.5. Sorry about that.
2 kilograms.
Sure. Why not?
I don't know. One half. One half. 1 pound and a half.
Pound and a
1.5 pounds. Oh my god.
No, you gave me a mixed number. I'm gonna write a mixed number. Nick, what? 1 pound?
Are we gonna do anything for Pi Day?
We're gonna learn calculus. Anyone else?
It's a B day.
So my B day is gonna learn calculus. All right, ready? Reveal. I think 2.5 is right. Oh, 2.
Ah, bro.
Wait, I didn't say kilograms, I said pounds.
What?
Kilogram.
Liar.
You gotta go recording, play it back.
No. All right. So what we're gonna do today is called alternating series test. When you hear the word alternating, what do you think of?
Back and forth.
Back and forth. So we are going to be alternating in sign. So we're going to have positive term, negative term, positive term, negative term, positive term, negative term. No, let's stop now. Because otherwise I have to go through infinity and that's boring. All right, the cool part about this test is this test, if it works, we're just going to write the same sentence every time. Were you hoping to go to math class and write a sentence today? Yeah. If it's the same sentence every time?
One of those, like,
I don't know, bro. I haven't.
if this is true, then you just divide the series of like.
I mean, kind of. All right. So, in an effort to be very clear, remember I said I was going to be picky about notation? This sentence that we're about to write, I'm going to be real picky about. So I'm going to try to model it for you so that you know how I'm going to be picky, because that's how I'm going to grade it. So alternating series test. The first thing, how do we know if something is alternating? Well, we could list out the terms, but that's kind of boring. So what do you notice about both of those series that I put right there? Is there something in there that might make things alternating? Yeah, does everyone see this -1 to the n or -1 to the n plus 1? Think about what would happen if I plugged in 1, then 2, then 3. -1 to the first is -1. -1 to the second, +1. -1 to the third, -1. -1 to the fourth, +1. Same thing if I have n plus 1. It's just going to alternate in sign. So oftentimes, I'm not sure if this is an official word. I'll call this our alternator. Would it be OR or ER? Alternate. I'm going to go with OR. So that's usually what we're going to look for if we want to find an alternating series. Now we're going to have some other ways to do that I'll show you, but that's generally the one that we're looking for. So when do I use alternating series? When I see something that will make my signs alternate. So this one tends to be a pretty easy test to figure out if I want to do it. So the two conditions we have to meet to say if something will converge by alternating series test is we need it to alternate, it being the terms. We need the limit of the terms without the alternator to go to 0. And then what do you guys think this means? The n plus 1th term is less than or equal to the nth term. Don't think too hard. So if the next term up is less than the term before it, they're getting smaller. What's a math way to say they're getting smaller? Decreasing. So these 3 words or 3 sets of words are the words that we're going to really be using. We're going to check, and this is going to be in our sentence, if the terms of our series, so the actual things we're adding together, do they alternate in sign? So do they go from plus to minus, or vice versa? Do they decrease in magnitude? So if I disregard the sign, are they getting smaller? and do they eventually get to zero? If I can say yes to those three things, then I converge by alternating series test. Now, is there anything saying I diverge? No. So we are not ever going to say diverges by alternating series test. Usually what's going to happen is either this is going to be false. Usually if we're looking at alternating series, usually this one is false. And if the limit's not zero, then we're saying we diverge usually by nth term. So if we have a limit that's not zero, I literally just gave it away. Usually we're going to say diverges by nth term here. So we're just going to go through a couple of these tests, see what's new, see what's different. And then we're going to have kind of a strength in convergence that we're going to talk about in a second. So we'll probably try to do like, how does 4 or 5 questions sound before a break? Sounds great. All right. So I'm going to show you my scratch work and my official work. My scratch work is not enough to earn points. So here's the official work here. So my scratch work, I like to do my scratch work first to make sure alternating series test is going to work. Because kind of like nth term, only one direction is going to work. So I don't want to like pull out all the official business if it's not going to work. So our 3 things. The first one, will this guy alternate? Do you think he will? All right, just this one time, let's go ahead and let's just confirm that on the side. So will you, for me, take about 10 seconds, and I want you to plug in the first term to find the first term of the series. What number are we plugging in to find the first term? 1, because it says n equals 1 on the bottom. So I want you to plug in 1 very carefully. I want you to tell me what the first term of the series is. Yeah, is it positive or negative? Positive. Oh, what's the next term? All right, next term.
Negative. Oh.
All right, so we would be plugging in, we plugged in 1, we plugged in 2, so now I'd be plugging in 3. So I'd have, we plugged in 1, we plugged in 2. Positive 1/3. Whatever's on the bottom. All right, then I would plug in 4, negative 1/4. All right, so as I go, you can probably tell what the next couple of terms are going to be. Does it look like these terms are alternating? Yes. Now I could see that by listing out the terms, but if you have something that looks like this, the -1 to the n plus 1 or -1 to the n alternating, yes. All right, the next thing we need, do these decrease in magnitude? Now I'm using abbreviations here because this is my scratch work. This is not my official sentence. Are they, disregarding the signs, so not the pluses and minuses, are the fractions getting smaller? Yeah, 1 is bigger than 1/2, is bigger than 1/3, is bigger than 1/4. They're decreasing in magnitude. All right, the last thing, the limit as n approaches infinity of the stuff without the alternator. So the 1/n, where does that approach? It does, it approaches 0. So this is my scratch work. Here's my official answer. What color makes you feel official? I like that everyone said red. So here's my official answer. All right, since my terms, what were the 3 things? Alternate. Wow, look at me using the whole word alternate. What was the next thing? Decrease in magnitude. Dec in mag means nothing. Sorry, I just had a flashback to arguing with a boy named Trevor Kapov because he liked to write dec in mag.
Well, that's so funny.
Yeah, say it on video. He would appreciate that, actually.
We're allowed to do everything.
No. And the limit as n approaches infinity of 1/n equals 0. What is my conclusion? Since those 3 things happen, what happens to my series? Converges by What test? Alternating series test. AST, okay. Now, let's think about this. Literally, we were checking off conditions. Only one of these conditions could possibly change if this test works based on the series. This thing right here that I've highlighted in yellow is really the only part of this sentence that should ever change if I'm using alternating series test. Because if I'm using this test, the terms should always alternate. They should always decrease in magnitude, and the limit should always be equal to 0. So really the only part that I have to switch out is what that kind of nth term without the alternator is. Yeah.
So are we just writing it down and then seeing it?
Yep. So you kind of want to do scratch work either in your head or on your paper. Are these 3 things true? And you're writing literally that sentence with maybe the yellow part switched out every time. Yeah. Oh, it doesn't matter. So I need full words for alternate, especially decrease in magnitude. Like those aren't acceptable shortenings. And you could write, instead of the limit, you could write and have a limit of 0 if you wanted to write words. And then this will always be converted. Yeah, and symbol's fine. All right. Yes. All right. Does anyone notice that this series kind of looks familiar? It looks almost like another series we did. Maybe if I cover up this. It looks like the harmonic. What did the regular harmonic do? Diverge. What does the alternating harmonic do? Converge. So it's like the very borderline of being a convergent divergent series. In the future now, this one you can say alternating harmonic. And we can just know that converges. All right, so he, again, so especially has a name. And I think the reason we name those is because it's such that borderline series of being between convergent and divergent. So if I make the terms alternate, this does have a finite sum, whereas the regular harmonic does not, it diverges. Yeah. If it's just the alternating harmonic, so literally that series right there, or maybe the negative one, just the regular n of 1 over n, you can call it the alternating harmonic, be done. But if it's like 1 over n plus 1, that's no longer the alternating harmonic, and you have to do the whole series test.
Okay, but if it is just the harmonic,
Yep. All right, let's look at another one, and then we're going to kind of keep moving because this test is kind of boring in and of itself. So let's see. So here's my scratch work. You could do this in your head, on your paper, whatever. What's the first thing I'm going to check for? Yeah, if we're looking to use alternating series test, does it alternate? Do you guys, I don't want to list the terms this time. Do you think it's going to alternate? Why? Just because I put something on the nose doesn't mean it's an example of something. You know me, I like to throw in a trick here and there. To me, this is really obvious that it alternates. Yeah, -1 to the n power. That's going to flip back and forth as I plug in even and odd powers between positive and negative numbers. Again, alternating series test, he's not hiding anywhere. He's like, hey, yo, I am alternating. -1 to the n, -1 to the n plus 1. So this is true. All right. Do you think the terms decrease in magnitude? Meaning, as I plug in bigger and bigger values of n, do you think that fraction will be getting smaller and smaller?
yes.
I think so. That 2n is growing faster on the bottom than the n on the top. Let's talk about this guy, the limit as n approaches infinity. I'm going to disregard the alternator and write everything else down. Exactly. Thank you, Nicole. All right. We've done a lot of limits like this. What's this limit equal to? I heard someone whisper it. 1/2. Is it supposed to be 1/2? No. That's not equal to 0. It's supposed to be 0 because our terms are supposed to be getting smaller and smaller. Now, am I going to write diverges by alternating series test? No, this is a test for convergence. What could I write instead? All right, so I could write diverges. Synonyms. So diverges by what test? By nth term. Now you may be concerned about the fact that we did this limit without the alternator in it, that's actually enough, because with the alternator, that limit would be more so oscillating towards positive 1/2, negative 1/2 as we reached infinity. So saying that without the alternator, it's not going to 0 is enough to say that this will diverge by nth term. Looking at these have the same powers top and bottom, so I'm taking the ratio of their coefficients. All right. Just as a note, one of the biggest mistakes notationally I saw in the test did have to do with nth term test. A lot of people were not doing the limit, but just saying this like equaled 1/2 and then saying diverge. Please don't write this down because it's very wrong. This is a problem, because if I say something diverges, but then it equals a number, I'm claiming that this converges and the sum is 1/2 and this diverges. There's a lot of nonsense happening there. So please make sure that you're showing all the work. You're going to see those in the notes I made on your quizzes, but we really have to be careful about our notation. All right, I would like to do a couple more questions. And here we're going to get an interesting situation. What you may notice is that we now have different types of convergence. Specifically, going back to this one right here, this series is something that converges only if the alternator is there. So if I take away the alternator, this series will diverge. So we've got kind of levels. Here are your 3 levels. If your series diverges, it just straight diverges. There's no levels to divergence. That's just bad. If your series converges, it can do one of 2 things. It can absolutely converge, and it can conditionally converge. I like the word conditionally the best for making sense of this. Conditionally convergent means that I need the alternator to make it converge. So if I remove that alternator, which I'm doing by doing the absolute value bars there, because that'll get rid of whatever sign changes I have. If that diverges, but with the alternator I converge, I'm called conditionally convergent. If I absolutely converge, it means the alternator doesn't really matter. So a good example would be like -1 to the n over n squared. 1 over n squared without the alternator in it, that's a p series. P equals 2 greater than 1. We converge. The alternator isn't really doing anything to the convergence itself. So how do I do a question like this? What does it mean? We're essentially just going to do a test twice. We're going to work on, does this converge at all using alternating series test? And then if I remove that alternator, what can I do to kind of figure out an answer? As a note, if we absolutely converge, the word in there, converge, is there. So if something absolutely converges, then it does just like generally converge. So you guys ready for math to get exciting in? I love factorials. Mostly I just like factorials. What?
Wait, no.
This guy? N. It's not just like that. It's just like n times n minus 1 times n minus 2 times n minus 3 all the way down. Factorials are just fun. All right. So let's start with, all right, so do you guys see the alternator? Yeah, we see him. As soon as we see the alternator, we're like, alternating series test. Also, this is talking about absolute or conditional convergence or divergence. So we have 3 choices. We're going to try to choose between those 3 choices. Really, the choice we're making right now is converge or diverge, just like normal. So got my scratch work. Do we alternate? Yes. Yep. And if you're not sure, you can always, like we did in the first one, you could always start plugging in terms, making sure that sign moves back and forth. Specifically that -1 there, that's going to switch our sign back and forth. All right. What was the next thing? Decreasing in magnitude. Do you think it decreases in magnitude? Yeah, so I'm gonna put a question mark here. I'm not really sure yet, because I'm not sure 2 to the n versus n factorial. I think I might need to do some more investigation, and I think that investigation might be easier to do with this limit. So n factorial over 2 to the n, disregarding that alternator. So let's do a little investigation here. Give me a slightly large number. That is large. 6, great. Sorry, that could have been anything. I was mostly just hoping someone would read my mind. Thank you. All right. So let's look at, I'm just going to plug in 6 to this and compare the size of the number. Because I think, kind of going back to what Connor was saying, I feel like n factorial gets pretty big, but I just want to compare really quick. When I want to compare things and I'm a little confused, let's just pull a number and see if we can figure out. So what does 6 factorial mean? Anyone remember factorial? 6 times 5 times 4 times 3 times 2 times 1. And 7 factorial, I added times 7. 8 factorial, I added times 8. What do you think about 2 to the 6th power? How many 2s? 64.
No, it's not.
Oh, maybe. Is it? I don't have an actual number.
I was right.
Is it 720?
Yeah.
All right. And this one is 64, right? I know 2 to the 5th really well. It's 32. So I'm hoping I can multiply by 2 again. All right. So we've established using our number here that the factorial is bigger than the 2 to the 6. Do you think it will continue to be bigger than the 2 to the 6? Why do you think it will continue to be bigger? Yeah, if I go to 7, I'm multiplying by another 2 here, but a 7 here. If I go to 8, I'm multiplying by 2 more 2s, but a 7 and an 8. So do you guys agree that factorial will be growing faster? There's a lot happening. Very distractible. Do you agree that factorial will be growing faster than this exponential 2 to the whatever? All right, so let's pull this back to calculus. Where do you think this limit's going if the factorial grows faster? Yeah. Yeah. So here's a good what if question. What if the 2 on the bottom had been like a 4 on the bottom or a 7 on the bottom? Do you think that would ever catch up with the factorial? No, because the factorial eventually, if you think of like infinity factorial, what? They're going backwards? What does that mean? Yeah, Michael.
So n factorial was on like they were reversed.
Yeah.
Then it'd be approaching 0.
Yes, another good what if question. So Michael said if we reverse them, if 2 to the n was on the top and factorial was on the bottom, that would go to 0. That would be much better for our situation here. Exactly. Mm-hmm. All right, so let's revisit. Why do I care about this infinity? It's not 0, right? So what could I write as my conclusion to this test? Diverges by nth term. Now, if we get something that diverges, we don't have to check for absolute or conditional convergence because it doesn't converge. So we're going to do the next 2 questions are going to be quite a bit longer, specifically the second one that we're going to be doing, because spoiler alert, it's going to converge and then we have to then check for more stuff. Yes. Yep. So I would need, that's a good question. What do I need for my work? The stuff I would need is this limit and diverges by nth term. All right, let's look at this next one. What the heck is that numerator? Some trig? There's some cosine in it? Well, it's not, so. All right, let's look at, so if that were in a regular function, that would creep me out a little bit, but we're only plugging in very specific numbers here. So let's try to list out some terms. Why not? So if we plug in, what would we plug in first? So we'd have cosine of just pi on the top, right? What is cosine of pi? -1. So this would be -1 over square root of 1. All right. if we plug in, what's the next number we're plugging in? 2. So that would be cosine of 2 pi. What's cosine of 2 pi? 1. All right. How about cosine of 3 pi? Because we're plugging in 3 next. That's the same thing as cosine of pi, right?
Oh, it just goes around the circle, right? Yeah.
Thank you.
Oh, yeah.
All right. What about cosine of 4 pi? Yeah. So is this a very creepy way to tell you a series is alternating? Heck yeah, it is. Yeah, so this is kind of like a disguised alternator. If you see cosine to the pi n, it's a really creepy way for me to say, hey, this alternates. Yes.
Is this the only other hidden alternator that we know about?
That you should know very clear in your brain. Yes, I could probably finagle one with like some sign stuff, but it gets a little harder there. When in doubt, though, you can always plug in and see what your terms do. So if I saw this, I'd be like, that cosine is trying to tell me something. I don't see trig in my series all that often. Like, how many times have we seen trig in our series so far? I can't think of any. So this is trying to tell me something here. So let's do our scratch work. Do my terms alternate?
Yes.
All right. What's the next thing? All right. Looking at these without the sign changes. So we've got 1 over the square root of 1, 1 over the square root of 2, 1 over the square root of 3, 1 over the square root of 4. Are they getting smaller?
Yes.
What am I taking the limit of? 1 over root n, disregarding the alternator. Where does that limit go? Have we satisfied all the conditions? All right, sentence time, boys and girls. Since terms, can I write alt?
No, you also cannot write that in mag.
But you can write it,
But you can write things.
and you can also,
And limit as n approaches infinity of 1 over square root of n. Yes. Technically, with the alternator, that's still true, but the test in and of itself has without the alternator. If I plug in infinity on the bottom here, 1 over infinity trending towards 0. All right, my series nope, that's not the word I wanted. What's the word I wanted? Converges. Yes. Right. So there's only one type of divergence. I just diverge. What I believe Connor and Michael are noticing is that I now have more to do in my question. We won't need a lot of room at the bottom. So if you're running out of room, that's totally fine. I do want to point out 2 words that often get mistaken for each other within this series test. The use of terms at the front end and series at the back end. Please do not use series in the first part. Your series doesn't alternate. Your series is a number. It has a sum. We don't know what it is. The series doesn't decrease in magnitude. The series is a number. Those terms alternate. Terms decrease in magnitude. The limit of the terms is 0. Yes. Yeah, so that's kind of saying, because technically these terms, if I just use them with the negatives and positive, these terms don't decrease. They're going from a negative up to a positive. So that in magnitude is saying, hey, disregarding the sign.
it's like if you're applying that.
Exactly. Sorry, I'm getting really distracted. All right, so now that we figured out convergence, let's look at the directions again. This said determine the absolute or conditional convergence. So these are different directions than we've had before. These directions mean I need to do more work. Right, the next one. What? Yes. Yeah, so Charlie's asking a really good question. If this just said determine the convergence or divergence, I would be done. So like on your problem set, the ones that are saying just does it converge, does it diverge, those first ones in all of the chart, you could be done right here. The only one where you're going to have to do what I'm about to do is the one that's in number 19, where it says determine the absolute or conditional convergence. So if you just ask, does it converge, you're good to go. So for my more work now, I'm going to consider the series where I drop the alternator. I'm technically doing the absolute value of it, but really, what was the alternator in this question? The cosine. So I'm going to look at this without the cosine in it. So I'm going to do 1 over the square root of n. All right. What kind of series does this one look like? Ooh, okay. I'm hearing someone mention P series. Could I rewrite this as a power on the bottom? 1/2. Cool. All right. So is this a P series? Yes. What's P? Thank you for not answering that sarcastically. I don't know. I just asked what's P. That could be interpreted differently. All right. 1/2. Why do I care? It's less than 1. Sorry, distracted. It's less than 1. What does that mean about this P series? It diverges. So let's go back to the original question. We got that the series itself converges by alternating series tests. We got that the absolute value diverges by P series. What is the answer to my question? This guy is conditionally convergent. Now, how often am I going to ask you to do all of that process? Maybe like once on a test. Because most of the time we just care about converge, diverge, not what type. All right, I'd like to try the next question, and then we're going to take a solid break. Now, I heard James earlier go, whoa, what's going on there? And I would agree. That exponent is heckin' weird. Yeah, if you're creeped out by it, it should look like this. So what I would like you to do, this is a good thing to figure out. So if anything is ever super creepy in a series, I would say this qualifies as relatively creepy. Listing out terms can really help me know what's going on. And when I say listing out terms can help me, it can also help you, you know? So I would like you to list out 1, 2, 3, 4. Let's try 6 terms. All right. I would like you to try to list out 6 terms of this series, mostly focusing on that perhaps alternator on the top. If it's not just -1 to the n, it's not just -1 to the n plus 1, there might be more going on there than I can see. So I'm going to give you 3 minutes to list out 6 terms. That is way too much time. You shouldn't have to do that. Because you can't do that. That would be I.
1 plus 1 is in fact 2. That's true. That's insane.
Then tell me how to know whether it's
Yeah.
This
at the end of class, the first 2 different numbers are equal to this.
That's correct. 3 plus, no, 2 plus 1 is 6.
Oh my God.
Oh yeah.
When you don't start your timer.
It's just 3 to the 3, buddy, okay? Calm it down. No, please go.
Man, this was gonna be one. Well, I'm gonna go.
So I cut myself now, it's 3 plus 1 is 4. I just can't hear these numbers. Okay, 12 divided by 2.
6.
You're losing me, man. I need to
What's 3 to 6?
You wanna walk you through it?
Oh. Is it just numbers?
Alright, there we go.
Times 3. Oh, it must be 2.
Once you learn enough hard math, the easy math gets difficult.
Yes.
All right, once you have your 6 terms listed out, I want you to fight out with your neighbors. Is it alternating? Does that count?
And it's a term. Yeah, it's just one over 3.
Yeah, that's fine.
I think that's the bottom number.
Too big?
Yeah.
Why?
What's 243 times 3?
729.
Big.
Do 200 times 3, 20 times 3, 9. Or 40 times 3, 9, 3 times 3. What am I even saying? All right, help me out. Who knows the first term? Negative 1/3. Then what's the next term? Then what? Then what? Hold on, let me get my 6 terms. Then what? Then what? Oop. All right, do you think it's gonna be a plus or a minus next?
Plus.
All right, my question. Is this alternating? No. No, and we can't see that this pattern is definitely going to continue. Maybe you can, and that's true, but this is not alternating, and thus we cannot use alternating series tests on it to say whether it converges, which is unfortunate. So let's throw a deep Hail Mary pass to use a football metaphor. Sports. So if we can't say this converges with alternating series tests, and I can't think of a different test to use, one thing we can do, and this will come up very rarely, but it's a kind of cool example, so I thought I would show it. Also gets the idea that listing out terms is helpful, is we can try to look at the absolute value of this, because if something absolutely converges, then it definitely just converges. So let's look at what happens if I take the absolute value of this series. So I take this -1 all to this stupid power, and I will agree with your comments that this is a stupid power, or maybe just my own comments. What will the absolute value bars do to that term there. Mostly the numerator. What will it do? Yeah, it's just going to be 1 because that top part, that -1 to the n times n plus 1 all over 2, that's either going to be -1 or +1, right? All right. And the absolute value of -1 and +1 is just +1. So this series is going to look like this. All right. So I've simplified it a lot. Does that look kind of familiar? Ooh, geometric's a good idea. How could I make it look more geometric? 1/3 to the n. All right, so we're claiming it's geometric. What do we look for in geometric? Whether what's greater than or equal to 1. The thing in the parentheses, what do we call it? R, the ratio. And remember, with our absolute value bars, we're looking at the absolute value of 1/3, which is 1/3. Why do I care? So what does this series do? Converges. Yeah, so by geometric series test, but we just said the absolute value of the series we were originally talking about converges. So we can draw a couple of conclusions here. One, the original series, that is not how you spell original. Hold on. So the original converges, and to be more clear, converges absolutely. So with absolute value bars on it. Now, normally your process would look more like this middle one, where we would be able to say converges or diverges with alternating series tests, then we would go. But if you can be bold and go first for the absolute valued one, you do get that initial conclusion as well. All right, so as we move into our break, going to give you a little bit of a preview. We're actually kind of done learning about alternating series, the test. We're going to talk about kind of two things before we leave. One is, well, actually more so one thing. We are able, because of alternating series tests and the way the terms work, we are able to get a bound on what's called our remainder or our error. So if we stop the series somewhere, how far off we are from our actual sum. So we're going to talk about that remainder. And then at the very end of class, I will prove that two numbers are equal to each other because of Riemann. So, yeah, Riemann. He's back at it again. All right, 4 minutes. Take a break. Yeah. So I'm saying that this original series, I just didn't want to copy him down. He converges, and not only converges absolutely.
Oh, and it's absolutely, does that mean when you use absolute
Because the one with the absolute value converged.
Oh, okay, because then the other one.
Yeah, so like in this process, if I want to say converges absolutely, I would have gotten converges by AST, converges here as well. Let me. Connor. No,
Yeah.
I chose them. So if you hate them, be mad at me.
So -1 to 1 is -1. 3 to the 1.
What?
Like you chose like most likely to win or whatever.
Trying to spread the wealth around.
Vince is on like all of them.
Because I think he had like a whole group of friends vote for him. Yes, it's up now. If you want to vote for senior superlatives. It was hilarious to see the data because there are a few people who like voted for themselves for everything. Which like, there you go. Just like try to make yourself.
One of my friends wanted to fill it out for them, and for the rest, I just put myself in.
Yeah. Like, why not? Make yourself win. What was I looking at? Desmos. Yeah, is anyone going to submit a speech?
No.
Yeah, I already have a speech already. To be the graduation speaker. We don't bring like an outside person in. Yeah, so what Jackson did last year. No, probably. Where is my alternating? Where'd he go?
I thought it was a new rich girl talking.
I can't find it. Oh well.
Stephanie,
Yeah.
if I go to the basketball game on Thursday, will my test be pushed back?
We're not taking a test on.
Yeah, but we're.
No. Because the notes will be posted and we'll have a day in between.
Are you going, Michael?
I don't know.
How many people are skipping my class on
There's gonna be
Thursday?
a lot of people.
I'm not, I'll be here. Because I have a test.
What if we all skip one?
Considering I gave a quiz on Friday when 11 of my 23 people were gone in 7th block. Yeah. No, we're just gonna roll. We don't have time to stop, so can't stop, won't stop teaching ish. Yeah, I might have one thing after. I know. I want to be done really bad. Actually, wait. Let me look at mine. Yeah, I have 10.4 afterwards right now. We might do 10-1, 10-2, do like a review day, and then split 10-3, 10-4.
Yeah, everyone's gonna do scholarships. Even doing like the top 5 in the nation is gonna get a full ride scholarship.
Where did
From law schools, but he's probably but he has like actual records. Yeah. But he runs similar areas.
Oh, also, last year they made us get rid of all the like negative ones too, which I think those are funny, but we weren't allowed last year, so I just went with the same thing.
Press procrastinators.
Like we couldn't do that one last year. It got nixed. Dr. Al was like, no. You know, she hates fun. Yeah.
Okay, no, you can't vote, but you can tell people to like vote for me.
No. Vote for Lily. I don't remember what you're on. All right, let's get these notes done. So, alternating series remainder. Let's talk about remainder and error. Again, one of the hardest things, if not the hardest thing we learned this year, will be called Lagrange bound for error. Similar vibe, Lagrange. He's a French dude. For the purposes of our class, remainder and error have essentially the same context. So what that means is, let's say I take this infinitely long series. So I've got infinitely many terms. And after like 5, I get tired. And I'm like, that's good enough. What this remainder is going to tell us is how far are we from the actual sum. So how far am I if I add up 5 terms? How far am I from if I add up all infinitely many? Now, that question is actually really hard to answer of exactly how far off, because I would have to actually be able to find the sum to make that happen. And we've figured out there's only 2 types of series where we were able to find the sum. Anyone remember what they were? Telescoping, our uncanceled terms. Geometric, remind me that formula. A over 1 minus R. So what we're actually going to find instead of the actual remainder or the actual error is we're going to find a bound for that error. When I say the word bound, I want you to think of like an upper bound. So this is going to be like a number that's definitely bigger than how far off we are. So let's kind of verbalize that again. The approximate sum. Essentially, I'm going to take the first n terms and add them together. If I'm lazy, could be 6. If I'm feeling fancy, could be 100. But I'm just going to add them all together. Now, the way alternating series usually are written, we're going to alternate the a sub n formula. So this would be like the first term minus the second term plus the third term minus the fourth term plus ... and then either plus or minus the nth term, depending on whether it's even or odd. So what we're going to do, I'm going to throw some notation up here. It's going to help us as we move forward to this Lagrange thing at the end of Unit 9. So remainder and error can be written in a couple of ways. our remainder for however many terms we went. So if I went 6 terms, that would say r sub 6. This is the same. Here's just 2 different pieces of notation as if I take the actual sum and I subtract whatever my approximate sum was. So again, if this had been 6, that s would stay the same because the s represents just the sum minus s sub 6, which is my 6th partial sum. The important part here, the cool thing that I can conclude with alternating series tests. Let's say I start here. I'm going to go up to this picture for a second, and I move over with my first term. Would you agree that this is definitely too big here? Because the next term I'm going to subtract off. So this term, definitely too big. As I go to the next term, definitely too small. Next term, definitely too big. Next term, definitely too small. But one thing that I can conclude, since these terms are getting smaller and smaller, the next term up is way definitely bigger than what that remainder is. So if I went over here, this term right here is definitely bigger than how far off I am from the next sum. So a very easy way to find the error bound, meaning something that's bigger than my error, is to take the next term up. So this is definitely less than my n plus 1th term. And I'm putting absolute value bars around it just to remind ourselves we don't want to have like a negative error here. We're talking about how far off negative wise. So I'm going to show you the 2 different ways I can ask about this question. One would be to find a bound for the error, and one would be how many terms do I need to get within a certain error bound. So let's first take this series, looks harmonic, but is excited. So we're 1 over n factorial, not harmonic. We're going to find the first 4 terms. So the 4th partial sum, I would call that s sub 4 if I'm feeling notation happy. All right, can you take a second in your head, find me the first term of this series? Let's start with, is it positive or is it negative? Positive. And everyone remember what 1 factorial is? It's 1. So the first term is 1. Next term would be negative 1 over 2 factorial. Next term would be positive 1 over 3 factorial minus 1 over 4 factorial. Let's go ahead and simplify a little bit. Everyone know what 2 factorial is? Freshman. All right. Oh, I teach them a lot. All right. What's 3 factorial? What's 4 factorial? You can take the previous one and add it, multiply by the next one. All right, I went and added these all on my calculator. Pretend to be our calculator right now. I would get 0.625. Now, is that the actual sum? No. Is it probably pretty close? Yeah, maybe. Let's figure out how close. So we are going to use the alternating series error bound to show that this approximation differs from the actual sum by less than 1 over 100. It's a lot of words to say, let's show that the next term up is less than 1 over 100. So here's some notation. We have our remainder or our error. So these first 2, you can kind of use either way. So this is more of a preference thing, whichever notation you care about. This is definitely less than the next term up. So a sub 5. So this is our error bound. All right. What would our 5th term be? So we had our first was 1 over 1 factorial. Next was 1 over 2 factorial. Next was 1 over 3 factorial. 1 over 4 factorial. Yeah, 1 over 5 factorial. Now, can you guys find while I close this door for the hooligans that are outside? What is 5 factorial? All right, 1 over 120. We would do that by doing 5 times 24. Now, is that number less than 1 over 100? Yeah, do you notice how the numbers are kind of similar in magnitude? A lot of the AP test questions try to help you out by making those numbers relatively similar. So what I've shown is that my error, this is my actual error, is definitely less than this because my terms are alternating, decreasing in magnitude, and they have a limit of 0. So this does converge with alternating series test. So this error is definitely less than the 5th term, which is less than the thing in the question. Yeah, so this one is like if I could actually find the sum and subtract the partial sum. So this would be actually how far off am I exactly? We can basically never find that because we can basically never find this sum here. So we're getting a number that's definitely bigger than that. So like an error tolerance. So think if you like worked at a factory, I don't know exactly how far off all of my things are from whatever I want them to be, but I might have a certain tolerance that I'm allowing in this, and that would be like my error bound. So one way I can use this is I can show that my sum is within a certain interval. So we're going to use our results to explain why the actual sum couldn't be 0.7. I actually do know between 2 very specific numbers where my sum will lie. And that is if I take my partial sum and I either add or subtract this error bound. So if I'm within 1 over 1/20th, that gives me a very, very specific range. So this would be between 0.616 and 0.633. What? No, I didn't. I just try to like really zone that part out. Nice. All right. So could my sum be 0.7? No, it could not, because it's not in that interval. It's not within 1/20th. All right. The last way I can ask you this question, I'm going to show you a couple of different ways, and then I'm going to do a little fun problem for you. Yeah, you don't have to write down the last one because I wouldn't ask you to do it, but. All right, so exactly. Yep. So 0.7 not in interval. All right, the last one is how many terms would I need to approximate to be within this certain interval? So there's a lazy way to do this and a very algebraic way. I'm going to show you the lazy way first because I think it's much better, but it doesn't work all of the time. Well, it would if you had enough mental capacity, but here we go. So lazy way. All right, so since I know that the kind of next term up is my error bound, one way to find out how many terms I would need is just to start listing terms until I find one that's less than this number. So what I'm going to do for this question is I'm going to start listing terms until I find a term that is less than 1 over 1,000. So let's start with the first term. Can you just tell me, is it positive or is it negative? Positive. We would get n 1 plus 1 is 2 for negative 1 squared on the top. 1 to the 4th last time I checked is 1. So my first term is 1. All right. Do you guys agree that this alternator on the top is not fancy in any way? He's just going to go plus, minus, plus, minus, plus, minus. All right. So the next one's minus. What's 2 to the 4th? A little smaller. 16. All right. Next one's plus. 1 over 3 to the 4th. What's that? 81. All right. I didn't check yet, but is that smaller than whatever 1,000 yet? No, let's keep going. All right. 1 over, where am I at? 1, 2, 3, 4 to the 4th power. Small enough yet?
Would we have a calculator?
I would probably make it easier math. 256. 5 to the 4th. You could do 5 squared squared. So what's 25 times 25? She answered. Bigger. 625. Is it small enough yet?
No, the next one.
You think the next one will be? All right, I need to know what 6 to the 4th is. If you want to use a calculator, that's fine. I need to know what 6 to the 4th is. So I'd probably make the math a little bit easier than this. All right, is that smaller than 1 over 1,000? All right, so I'm going to draw a line right here. So why am I drawing the line right there? 1 over 1296 is less than 1 over 1,000. So the next term up is less than 1 over 1,000. So the number of terms I need is the ones up to that. So I need 1, 2, 3, 4, 5 terms. It's the worst 5 I've ever drawn in my life. Thanks. All right, so what I'm claiming is that my remainder at 5 is less than my term at 6, which is less than 1 over 1,000. You may be sitting here wondering, like, okay, what if it's not the 6th term that's less than 1 over 1,000? What if it's the 100th term? I'm not into this process if I have to list out 100 terms. So you can do this with algebra as well. What you would do is you would take your nth term and you'd essentially plug in n plus 1 because you want the n plus 1th term to be less. So I'd take the 1 over n plus 1 to the 4th. So just this term without the alternator plugging in n plus 1. And I'd make that less than 1 over 1,000. This does require a bit of algebra. I would probably cross multiply. So I'd get 1,000 is less than n plus 1 to the 4th. I'd 4th root this. So here I'd definitely need a calculator. And then I would subtract 1. So I'd get n is greater than the 4th root of 1,000 minus 1. Throwing that in the calculator, you would get a decimal. I'm just going to give us the decimal to talk about. You would get 4.623. Notice here we want a number of terms. So regardless of the decimal, I would want to round up. So I would get n is greater than 5 terms. 4.3 we'd still round up because we would want to make sure we have the full number of terms. All right, so that would be a really good option if you had lots of terms to go. All right, the last question you do not have to write down at all. In fact, I would say don't because I'm never going to ask you to do this, but it is a very, very cool conclusion brought to us by, did I put him in your notes or did I just pull a picture? There's a picture in my notes. Our favorite man, Riemann. Yes, Riemann of Riemann sums. Relatively brilliant mathematician. And he has this thing called the Riemann rearrangement theorem. It makes no sense to think about in your brain, but I promise it's true. And I'm going to show you one very specific example. So what his theorem says is if a series is absolutely convergent, so converges and then the absolute value converges, anytime I switch the order of the infinitely many terms, I will add them together and I will get the same sum. This is the weird part. If a series is conditionally convergent, so a good example, the alternating harmonic, I can rearrange the terms of the series to not only get a different sum, but any sum I want. I cannot prove this to you, but I'm going to show you that I can rearrange the terms of this specific sum one way to get a different number. So I'm going to prove that the natural log of 2 equals something else. Are you excited?
Yes.
All right. This is the alternating harmonic. That's what the terms are. We listed them out earlier. It can be shown using mathematics, not that I'm going to show you, that this equals the natural log of 2. So what I want you to do is just make sure everything I'm doing is legal. All right. I'm going to list the terms out with a little more space. Again, I would not write this down. I would just watch because I'm never going to ask you to do this. It's just cool. All right. So I'm going to write the first two terms. I'm going to skip the third and I'm going to write the fourth. All right. There's infinitely many. I can rearrange them however I want. Riemann said so. All right. Now I'm going to pick up the 1/3. And I want to skip down to the one that has a 6th in it. Can you guys tell me, will that 6th one be a positive or negative? Negative. Looks like all the even ones are negative, right? So I'm going to do minus a 6th. And then I'm also do the 8th one. So I'm going to do minus an 8th. Right now, you don't know why I'm rearranging this way. I can. Then I want to do the 5th one next. Is that going to be positive or negative? All right, positive a 5th. I'm going to do the 10th and the 12th. Those will both be negative. Why am I doing this way? I know it works. All right, now I want to group these. Why am I grouping them this way? Because I think it'll be cool. All right, I can have parentheses in, right? I didn't like change anything. I'm just like grouping them together. All right, will you guys help me? I want to simplify this stuff in parentheses. So what's a 1 minus a half? Okay, I'm gonna keep the 4th. All right, what's a 3rd minus a 6th? All right, I'm gonna give you about 10 seconds. A 3rd minus a 6th. A 6, because we got 2 6 minus 1 6 is a 6. Is it positive or negative? Well, this is what makes me sad. It's like all you guys understand so much complex math, and then you're like fractions. Just make them the same on the bottom. I don't know. Why do you care about that when I'm proving two different numbers are the same? All right. All right. What is 1/5 minus 1/10? 1/10. Is it positive or negative?
Positive.
All right. Despite our foray into not knowing what fractions are, do you now agree that those two statements are equivalent? All right. This is kind of looking like kind of familiar. They're all even on the bottom. How about we factor out a 1/2? All right, if I factor out a 1/2 of 1/2, what am I going to get? If I factor out a 1/2 out of 1/4, what times 1/2 would give me a 4th? This is now looking really familiar. Do you agree that this is the same thing as this? So this is natural log of 2. So I have natural log of 2 equals 1/2 natural log of 2. Infinity makes things weird. So what the Riemann rearrangement theorem means. So the weird part about this is a very convenient one where the rearrangement is kind of very algebraic, very easy to look at, a little weird to feel, but definitely not too hard to follow. The part about this theorem that I find the absolute craziest, not only could I make that equal 1/2 natural log of 2, I could make it equal pi. I could make it equal 5. I could make it diverge. I could do whatever the heck I want. If something's conditionally convergent, I can rearrange it to have any sum I want. Any sum. All right. I can't do it physically. Meaning anyone, if they had enough mathematical, yeah, you can rearrange it to have any sum. Oh, you can have parentheses wherever you want when you're adding and subtracting. Yeah, so essentially what you need to know from this, absolutely convergent, same sum all the time, conditionally convergent, any sum I want. Cool beans. All right, what I need you to do, I need you to find your problem set, and I have a very specific problem set task that I would like you to do before we leave today. It's green. Looks like this. Yes.
Multiply. Is it always like this? That's first.
So I like to think of multiplying by the 1,000 and then multiplying by this. So that's why the 1,000 ends up over here, and this one ends up on this.
Oh, so you like multiply the 1,000 over here and then multiply that over there. Is that how it always is in cross multiplication?
You don't necessarily have to do it if you have an equation, like an equal sign in the middle. With the inequality, you just have to really pay attention to what's on what side. So if you have an equation, doesn't matter. Inequality, it does.
So this, whatever over here, has to move first.
All right, so I have 2 tasks. You have a bare minimum task to leave today. I would like you to find and complete. There are 2 alternating series tests. So again, if you're looking at just in the front 14 questions, there are 2 that are just alternating series tests that just require me to write this sentence. So I'm going to give you 2 minutes to find them. One is definitely not it. No. I'm going to say 1 is a geometric. So I'm going to give you 1 minute just to find out what you think the 2 are.
Oh, yeah, it is.
We said we find or just the sentences. So if we can identify, we don't even have to write.
Yeah, so alternating series test is really one of the top priorities because I know I can get it right and I know I can find it. So that's usually like a confidence building one for me.
Fair.
You got to take the wins where you can get them. Save that integral test for the end. All right, so I think we found them. Can you tell me which ones are alternating series tests? 7 and 11. Yes. So just to be very clear, that is that sentence and that sentence only. I didn't ask you to do any sort of conditional or absolute convergence. It's just that sentence, perhaps with the yellow part written out. Again, you want to use the full words in your official answer, not just the scratch work that I'm doing. If you want to make sure, that's fine. Other things, these other 3 questions, 17, 18, and 19, mostly have to do with the error bound stuff we were talking about. So if you want to try those before we leave as well. We have 2 more tests to learn. I will tell you they have to do with numbers 10, 12, 13, and 14. Essentially anything to do with factorials that doesn't have an alternating series in it yet, we're not going to want to do. You're also not going to want to pull number 16. So I'll write those down. You will probably want to start working on your problem set kind of earlier than right before the test. So before you leave, I would like you at bare minimum to do those 2 numbers that we talked about, write your sentence out, and then use the rest of time to do something else in your problem set. My goal, get 3 questions done today, the 2 alternating series tests, and do something else.
Are we getting that?
Oh, I can't hand the quizzes back yet.
Oh.
All right, I believe 8 of you that still need to take the quiz, expectation, that should get done this week.
I will be in tomorrow at 8:30.
Perfect, yeah, if anyone wants to come in at 8:30, you're more than welcome to come in any morning you would like. I'm gonna also hand out some notes checks and things.
It's alternating.
All right, do you want another copy to work on while we're sitting here? Okay. Yeah.
I think it's yeah.
Yeah.
I only got one question then.
We worked on that, one of the classes we were at.
Oh, I was like, how do I use this?
Yeah, we started with it.
All I would be saying.
Not when we were young. Something else, something else. Yes. He was singing it, he's like, no, wait till it gets to the chorus before we get out of class. Yes, sir. Congratulations, I'm really proud of you.
I honestly feel like I remember this pretty.
Yeah, we didn't have all the time.
I'm at the doctor.
You started this year.
No, it happened last Wednesday.
So it was a really good look.
And I'm on like a good amount of opioids.
Great conversation.
All right, some of you guys that are getting notes like that, we didn't really finish these in class. Those of you who have to make up the quiz, you're probably gonna get a new version.
Oh, wait, I have.
It makes me feel better because that means that you're just.
Oh my gosh, are you crazy?
Hey, you got that one.
So this one, I just ran into the lane.
I think I did that. Okay, so that will be if I ask for it. So we got one right on the other.
Let's go.
Is 7 the case in which you would want to use the algebraic version of this?
Yes. So you can either get
Let's
that
go.
or you can try to start plugging.
Okay. I did that.
Yeah, like, Chris, have you like got a backstory legend?
So you need to know that Master does get bigger as you plug in bigger things.
So we don't need to do any of this.
Yeah, so you don't necessarily need to know how big it gets, you just need to know it gets bigger as you plug in bigger things. Hi.
Yeah, no, so what is endless?
Okay.
Is it possible for you to just write the sentence? You don't actually test it like scratch word.
It is.
Yeah.
Like, pretty over it.
I mean, like, must ask for like traditionally absolutely.
Okay. Think about it, whatever you want. I would try to push one. There's a lot of like.
I guess, I mean, you don't have to write out the scratch word.
Oh, yeah.
Yeah.
At least for these two, they were on. Scratch word. Yeah, I'm just gonna say that. Yeah, I think the next Yeah, I just don't really know what I have.
Bare minimum, so.
Well, if that's the case, then.
Yeah, you get there.
Dude, this is definitely the one. I'm using the other
Let's go, Nicole. Look at you. Go ahead.
Also, I love.
All right, can I give you guys some end of class announcements before we leave? So, end of class announcements. 1, we have one more day left in Unit 8. We're going to be doing 2 tests that are very similar and that you will enjoy because they involve a lot of canceling. They're called ratio tests and root tests. Of all the tests that we're doing, ratio test is the most important. So, we will be talking about that one quite a bit. He'll make a big old reappearance in Unit 9. Looking at the schedule, we have Thursday this week for 8.6. I'm going to make the 9.1 lesson as short as possible so we can maybe get about 20 minutes of problem set time on the 14th, but your problem set is due on the 14th. Highly recommended. Get started working on that. It's a long problem set. We'll round 1 on the 16th, probably round 2 on the 22nd, if I had to guess. Also, upcoming things. If you are missing that quiz, please take it as soon as you can. Ideally, really by the end of this week, make sure to schedule it. You can come any morning without announcement. Also, if you are, who is taking the AP test? Everyone in here? All right, if you're interested, Ms. Royce and I are scheduling a mock test. So if you want to come in and see what the full AP test looks like, mostly feels like, we're trying to schedule that for April 9th. I know that's the Saturday going into spring break, but if you're interested, I'll throw some points at you for class if you come in and you try your hardest. So look out for details on that. It's a good experience, kind of like they tell you to take the SAT twice. It's a good time to feel how bad the test is. So have a great day. I'll see you next time.
I was happy.
Yeah.
Time is healthy. Oh, yeah. And the notes check as well. Sorry, I mean, I have one for Bella.
Oh my God.
Yeah, can I have other copies? Thank you. And that's so like, I know we have that big notes that we just have access to. The only other notes.
Yes.
That
Yep.
like this. So like, when you do the considerations, do you do like the limit comparison?
Yeah,
And
absolutely.
then you would get,
Yep, I think that's what I did.
okay, and then like I just quickly like I just simplified. Is that okay? Like you'll know that I just did
Yep.
this over that. and just-
Yeah, probably if you were doing this on like a free response on the AP test, you'd want to be a little more explicit about how you're getting this
Okay,
fraction.
just because I just didn't have enough space. You want me to
Yeah,
like,
no. Go,
Okay.
Yeah, you're good. Bye. No, I thought you had one picture, you get 5. Great.
My power. To be very, bro, keep you played it.
Yeah, if I can, I'm aiming to do a second version of the places I've been taking, and I want to copy that. If I can get that today, I'll give you the whole version of the quiz. And we work on the morning and then.
And then I can take the one.
Just happy. Someone left it.
Thank you.
Thank you.
You got it. All right. Algebra 1. Y'all, I just proved 2 numbers that are different are equal to each other. How really? If you add up infinitely many numbers, Do you get a number or do you get infinity? Answer, it depends. And if it depends a certain way, then you can prove that the sum is equal to two different things. In a word, absolutely thrilling. Oh my goodness, why won't my...
Where's the test today?
We are going to postpone that.